Hey guys, Edward here from Edward279, the mixed content creator. The Pythagorean Theorem. It's one of those things in mathematics that, although it looks like a living nightmare on paper, is actually pretty simple and not that hard once you actually dive into it. But what even is the Pythagorean Theorem? How do you use it? And what do you use it for? All three of these questions will be answered in this video. First, let's get the facts straight. The Pythagorean theorem, just like a lot of stuff in mathematics, can trace its origins back to ancient Greece. And in the case of the Pythagorean theorem, the credit is often given to the Greek mathematician Pythagoras, which is probably who the theorem was named after. However, whether or not he actually invented it isn't too clear-cut, but he got the credit and the naming rights regardless. Secondly, the theorem only works on right triangles, which means it basically pretty much never works on equilateral triangles. As because all of the angles in a triangle have to add to 180 degrees, each of the three angles in an equilateral triangle has to be 60 degrees, meaning it's essentially impossible for an equilateral triangle to also be a right triangle at the same time. Okay, so now that we have the facts straight, let's get into explaining what it's for, what it is, and how to apply it. First up, what is it? Well, it's actually quite simple, as the Pythagorean theorem is just the term used to say this equation: a squared plus b squared equals c squared. Now, as for uses, the theorem is primarily used for two things: finding missing side lengths and proving if a given triangle is a right triangle. Now, for a couple of practice problems that show both uses of the Pythagorean theorem in action. Warning: complex mathematical terminology may be on the way, so if you need to pause the video to look something up at any point, go right ahead. Going back to the question at hand, you can see two side lengths that are given and then one that is missing. Now, the side length shown right here is what's called the hypotenuse, which is always the longest side of a given triangle. However, if the missing side length is just so happens to be the hypotenuse, it can be difficult to tell at times. Thankfully, in right triangles, there is another, almost surefire way to tell if a side of a triangle is a hypotenuse. It's that the hypotenuse is always the side opposite the right angle in a right triangle. In this example, the side with the number 10 is the hypotenuse, as that side is directly opposite the right angle of this triangle. But what about the other two side lengths, you might be asking me? Well, those other two side lengths are both legs. And in this example, one of them is given, but the other is missing. However, there is an order to follow when plugging the numbers and values into the aforementioned formula of a squared plus b squared equals c squared. Kind of. While the two legs can be plugged into the variables a and b interchangeably in order really doesn't matter for those two, the value that you plug into the variable c is always the hypotenuse. For example, if I were to plug the variables in like I don't know, this, that would be correct. Or if I went a different way and plug the variables in like this, that would also be correct. However, if I were to plug the variables in like, say, this instead, And oh, no, that's wrong. That would be wrong, however, as the measure for the hypotenuse is not plugged into the right variable and thus is in the wrong spot of the equation. Now, on to actually plugging the numbers in. Because we don't know the value of one of the legs, either a squared or b squared can be left as is. As again, the values for the two legs of the triangle can be plugged into the variables a or b interchangeably. For this example, I'll be leaving the a squared as is, and we'll be plugging in the 8 into the variable b. And because it was said earlier that the value 10 is of the hypotenuse, that value can only be plugged into the variable c, leaving this as the formula with the values plugged in. We're still anything but done, however, as we still need to do the actual math. First, square both the 8 and the 100. Square both the 8 and the 10. And if you did it right, you should have gotten 64 and 100. Leave the a squared as it is for now, however. That'll be taken care of later. Secondly, because it's a leg we need to find, we subtract the 64 from both sides of the equation, leaving us with this equation. A squared equals 36. I'll write it here. I'll write it up top as well so it's more visible. Finally, to get the desired result, square root both sides. Square root both sides. Doing so undoes the square and gives us 6 as the value of the missing side length and our final answer. Now, moving on to this question. Now, you may notice something different from the last question, and if you do, well, keep it up, because there is, in fact, a difference. The difference is that this time, it's the hypotenuse that's missing, and as such, the method to solve will be slightly different. So, let's get into it. First, plug the variables in, but since it's the hypotenuse missing, leave the c squared part as it is. Next, similar to what was done the last time, square both the 4 and the 6 to get, if you did it right, 16 and 36. Now, this next step is actually what's done differently depending on whether or not the missing side is a leg or the hypotenuse. In that first problem, it was a leg that was missing, so we subtracted the leg value we do know from both sides. In this case, however, the hypotenuse is the missing side. So instead of subtracting, we add both values on that side of the equation. Leaving us with the equation of 52 equals c squared if you did it right. Finally, the last step is just the same. Square root both sides to get a final answer of, well, it's actually really long. The final answer is actually really long, but for simplicity's sake, however, I'll round the answer to the nearest tenth, which gives us 7.2 as the value of the missing side length and final answer. Finding missing side lengths isn't the Pythagorean theorem's only use, however, and so I give you this. Now, you might be pondering just how the Pythagorean theorem can be used here, but there is a way. Earlier on, I said that the Pythagorean theorem can be used for two things. In those previous two problems, it was used for the first use, finding missing side lengths. In this case, however, all of the side lengths are given, which is where its second function comes in, proving a triangle as right or not. Since all of the side lengths are given, I'll plug them all in with the hypotenuse plugged into the variable c as always. And the values for the legs plugged into the other two. Now, similar to the other two, square all three of the numbers first to get 9, 16, and 25. Now, similar if the hypotenuse was missing, add the values for the legs to get a total of 25. Now, any of you angry folks in the comments that might be raging about how this helps to prove a triangle right or not, relax, as it's actually pretty simple. If both sides of the equation are equal to each other, the triangle is right. If not, then the triangle is not a right triangle. In this case, for example, 25 is obviously equal to 25, and thus the given triangle here is a right triangle. Finally, we come to the last problem in this video, and it's solved just like the previous problem. Plug it in with the hypotenuse in the variable c as usual. Just in the variable c as usual. You'll square all of the values to get 36, 49, and 100. And finally, add the two smaller numbers on this side of the equation to get a grand total of 85. In this case, the numbers on the opposite sides of the equation are not equal. And if that means anything, that means the triangle is in fact not a right triangle. So there you have it, the unusually detailed explanation of a formula that, although it looks frightening on paper, is actually pretty easy. We hope you enjoyed this video. Like, share, and subscribe if you want to, and as always, see you in the next video. Edward here from Edward679, the Mixed Content Creator, signing off.